जिनके पानी से भरे खदान में गिरने की बात कही जा रही है।
Jharkhand mine accident. 3 more bodies recovered. Toll rises to 7.
Our project is about AI-based RockFall prediction and alert system for open pit mines, and its description you can read over here. For our project, we will be following the 7 steps process. I will be giving the overview of these 7 steps, and further in the video we will discussing about each steps in detail. Initially in step 0, we will set up equipments. We will use a high quality drone with RGB cameras and laser sensors to capture images and measure heights at different points in the mine. We will also collect data from geotechnical sensors, rock movement, strain pressure, and record environmental factors like rainfall, temperature, and vibrations. For multi-image super resolution, we have thousands of images of mine. Here we will apply MISR, multi-image super resolution, in order to generate high resolution image of mine, which we will use in our further steps. In step 1, broad detection, we use image processing algorithms on MISR generated image. First one is slope discontinuity algorithm. This helps us to find areas where the slope of the rock suddenly changes, which are more likely to have rock falls. And the second one is edge detection algorithm. This outlines cracks and boundaries in the rocks, helping us to see where the rock surfaces are breaking or unstable. Now let's walk through to our edge detection code. It processes the mine image and highlights the edges clearly. This helps in broad detection of risk areas, making it easier to identify zones that need close monitoring. Of course, not every line the drone detects is a real crack. Some could just be shadows, loose soil patterns, or surface marks that don't pose any danger. That's why Rock Alerts uses process called structural filtering. It combines data from the orthomesic sensor with smart computer algorithms like the Canny algorithm, the Hog algorithm, and clustering methods. These advanced tools remove false positives and highlights only the true structural cracks on the mine walls and benches. Step 3, Finding imbalances. Rock Alert analyzes the stability of the mine slope by first collecting several surface points on the bench face. Using these points, it creates a best fit plane that represent the slope surface and then calculate the dip and dip direction, which are simply the angle of the slope and the way it is leaning. With this information, the system can determine whether the slope is balanced or it is starting to lean towards failure. Step 4, Model Prediction. In this step, the system combines filtered image data with real-world metadata such as rainfall patterns, seismic activity, temperature variations, pore pressure, and IoT sensor readings from the field. This information is fed into a multimodal AI model that uses CNN to process image features and LSTM to analyze time series data from sensors. This project builds a deep learning pipeline to classify rockfall risk using image sequences and tabular sensor data. The rockfall multimodal datasets loads groups of images and corresponding sensor features, treating each group as a time series. The collate groups functions pairs images sequences to handle variable lengths in each batch. We extract image features using a pre-trained ResNet 18 fine-tuned to produce embeddings. The train main function sets up data loaders, defines a multimodal CNN LSTM model, and trains it with augmentation and learning rate scheduling. For evaluation and testing, the model predicts classes on new data, reporting detailed classification. These are training and validation metrics and classification reports of model showing low, medium, and high risk areas. Step 5, Risk Area Calculation. Once the prediction is made, our system calculates exactly where the risks lie inside the pit. Using specialized geotechnical tools, it marks benches and slope sections as high, medium, or low risk. High risk zones glow red on the map. Step 6, Alerts and Recommendations. SMS email alerts and dashboard showing risk maps. Here is our dashboard. It fetches data from the model output which gives low, moderate, and high risk. Here it is depicted in the risk heat map. We have critical zones listed here where updates are happening in the real time. Now see the risk maps and visualization in 3D. Here it is a 3D model of mines with risk areas marked. We can apply filters on it like adding the weather conditions here such as rainfall, so the view of the 3D model changes. Geotechnical and other mine sensor data can be monitored here and tracked in real time. Now the predictive analysis section shows all forecast rockfall predictivity, and we can also set alert sensitivity from here and see all the predictive analysis. Step 7, Post-event update. After each slope event, whether it's a small rockfall or a significant failure, our system learns from the outcome. It updates its threshold and retrains its AI model using reinforcement learning. Over time, the system becomes smarter, more accurate, and better suited to the unique geology of each mine.